we need to compensate for the additional volume in the pool. And so, how many guests are going to be at the party? Well, it turns out there's going to be 18,000 gallons plus. Well, you gotta have the host as a guest too. Now, how much is the host going to eat? We don't know how hungry the host is going to be, right? And so that's an unknown. And so that's going to be X gallon. Because not only does the host have to feed the 18,000, but it also has to feed itself. Does that make sense, or is it not really making sense? And so if you look at our starting point versus starting at 18,000 gallons, if we started at 18,000 gallons and all the chlorinating solution only gave its chlorine to the pool, then we're okay. Because we started with 18,000 gallons and we found out how many liters of chlorinating solution are required, right? But in reality, we don't have 18,000 gallons. And so this was a mathematical mistake. We made a math error, or I made a math error. And so this is one final thing that I'm going to talk about, math and chemistry. But before I do that, I want you guys to do the calculation. To properly do this calculation, we have to compensate for the additional volume that this is going to be, right? Okay, so let's say, what should I do? What would be similar? What would be similar is like this. Let's say I have one hot chocolate here. And so I have one pack of hot chocolate. And I want to make a second cup. And how much hot chocolate is going to, how many packages of hot chocolate are going to be required to make the second cup? I'm just going to need one pack. So I need one pack of hot chocolate to make a second cup of hot chocolate. Well, how many packs did I just put in this one? I put one pack in here. So all I need to do is I need to pour this into here, and then I got my one pack of hot chocolate in this, right? So if I just pour this into this, then I got my one pack of hot chocolate there. Does that work?
It would be diluting.
It would be diluting, right? You're absolutely right. The same thing here. I need the chlorine to be at a certain level, so I'm just going to pour the chlorine from here into here. Well, it's not right because we're diluting. Right, and in chemistry, we have an equation, which I'll bring up later. It's called the solution-dilution equation. With the solution-dilution equation, that could be the second equation for this problem. The second equation for this problem could be solution-dilution. The first equation will be something else. But we haven't gotten to solution-dilution, so I don't want to talk about solution-dilution. I'm just going to talk about the cookies, or not the cookies, but the party, the dinner party, whatever else. You know, those analogies or something like that. That would be like this. Okay. And so basically, what's happening is this. We're adding all the chlorine from here, but we aren't compensating for, you know, this is like, okay, I'm going to add the whole pack of hot chocolate over into this cup, but I'm not compensating for the volume change that's happening, because this, of course, this has a pack of hot chocolate. And so if I just pour this, I got one pack of hot chocolate here, but that's not enough. Okay, this is my pack of hot chocolate. I'm going to pour my pack of hot chocolate in here, but it's not enough because this is a solution also, and I'm doing what's called a solution dilution. which means that I have to compensate for the hot chocolate that's lost. And so in other words, if these are equal volume, then I'm going to get half a pack of hot chocolate here and half a pack of hot chocolate here. Versus over here, what I'm doing is I'm pouring all this chlorine in here, and I'm going to assume that this guy, the host, is left with 0 chlorine. And all the chlorine went into the 18,000 gallons. Over here, can I do that? I'm going to just assume the host gave up all their hot chocolate over here. And so the host is left with no hot chocolate. All the hot chocolate went in here, but there's a problem. The host is part of the party now. It's intermingled. Over here, there's a problem because if I dump this in here, can I take it back? You know, I got 0.88 liters. I'm just going to take a bottle and scoop out that 0.88 liters out of the pool. Well, there's a problem because now all that chlorine's been evenly distributed. And if I try to take out that 0.88 gallon, you know, the host doesn't get anything. You know, it's impossible. Just like over here, if I try to scoop out the water from this cup and just give the pack of hot chocolate here, is that going to, no, that doesn't work because now the host is part of the party. Everybody gets a share. And so what I did in my previous calculation, although it's hard to see because it's a mathematical equation, you have to sit there. And this is what you have to do in science. In science, this often happens. In science, people go to a science conference and they go, what? You know, I don't really get that. What you have to do is you have to sit there and go through it, you know, either step by step or over and over again until it clicks, you know. And so what you have to do, you have to go back through that equation and then analyze that equation step by step. What are we doing here? What are we doing here? What are we doing here? And then see, you know, why all the chlorine from the chlorinating solution we're assuming is going in here, leaving the chlorinating solution with no chlorine. That's not going to happen. That's not going to happen because now you know, they're all mixed together. Okay, does that make sense, or a little bit more? A little bit less?
Yeah, like I said with the dinner price I give, right? And like I said, like if I had 6 guests, so I prepared food for 6 guests and then I fed them and then like I had none.
Yes, right. This is like, okay, we're planning for 18,000 guests, but there's 18,001 guests. So that one guest is getting no food.
It's the cook.
But in reality, that one person's going to eat. No matter what that one person's going to eat, that means everybody gets a little bit less food. You planned on 1 ppm. You planned on 1 entree per person. Well, everybody has to have less than 1 ppm. Everybody has to have less than 1 entree per person in order to feed this. We didn't factor in this. We just calculated how much we're going to need for 18,000. But in reality, it was 18,001, or maybe it's 18,002. I don't know. Maybe it's 18,003. This is an unknown. So we got to figure out how many extra we have to prepare for. But in order to figure out how many extra we have to prepare for, that's 2 unknowns. And if we have 2 unknowns, then we got 2 equations. And we didn't do that. We didn't do a 2 equation, 2 unknown problem. We just did a 1 equation, 1 unknown. And because, you know, when we did this, we had to pick a number of guests, 18,000. And we don't know how many extras. And so how can we figure out how many extras there are? Well, it turns out not to be that hard if we can do 2 equation, 2 unknown. And so why don't you try it? It's not that hard. Setting it up is hard, but the actual calculation is not hard. Solving for x is not hard. Does that make sense? A little bit or not? We could do a simpler one if you want. Well, I don't know. It's so much simpler, but you know, if you had a one, you have to be able to have a fraction. Food. So if you had one pound of food per person, that's our target. 1 pound of food per person, and you have 18,000 guests plus the host. And so this is per person. And it turns out the host can carry 7 pounds of food per host. And so what we did was we only calculated the food requirements for the guests. We didn't calculate the food requirements for the guests and the hosts. We have to calculate the food requirement for the guests and the hosts, but we don't know how many hosts there are going to be. If there are only 18,000, it's easy. If there are only 18,000, then we know we're going to need 18,000 pounds of food. But unfortunately, you know, we need the host to bring the food to the guests, and the hosts themselves are going to consume some food. There are multiple ways of setting this up. We don't have to set it up one way. And so how can we calculate how many hosts we will need? So this is a 2 equation, 2 unknown type problem. How does this come up in chemistry? How this comes up in chemistry is when we're mixing things together, and when we mix things together, then solution dilution comes up. We've got to factor that in.
So 1 becomes X and 1 becomes Y, and then we're going to substitute it?
Yeah, except not 1. Okay, this is the way I set it up. 18,000 guests plus the host will be the total number of people. And so the total number of people is what we'll call Y. People is Y. The host we'll call X. And so how do I know the total number of people without knowing how many hosts I have? Well, it's easy. I can just make up a number. I say I have 3 hosts. Well, if I have 3 hosts can only carry 21 pounds of food. Is that enough food? No, it can't be 3 hosts. Then I can say, well, if I have 18,000 guests, that means I need 18,000 pounds, and each host carries 7 pounds. That means 18,000 divided by 7 is how many hosts? Is that right? That would be right if the host didn't eat, but the hosts do eat too. If the hosts eat too, then you see I'm missing some information. And so this is a 2 equation, 2 unknown problem. Now, and what helps is just think about this for right now. Let's stop. We'll take a break. And then we're going to start the lab, and then we'll come back to this problem next week.
I have a question.
Yeah.
So it has the 18,000 with the host, or then the host added to
No, 18,000 without the hosts. Yeah, and the hosts are added to it. So like caterers would have to do this, right? If you're a catering food company and you need to feed your employees, you got to figure out how much food you're going to need.
I might have just made it more complicated for myself.
Huh?
But I don't know, I felt like this could kind of explain like the number of holes is equal to 18,000 plus the host minus 7 times the host. And I think I'm just confusing myself.
So you only need 2.5 hosts?
No, that's actually a common.
2,000?
171 hosts.
Okay, 2,571 hosts. You could just do an easy double check. And so that means you have 20,571
Yeah.
pounds of food required, right?
No, that's the number of hosts, so then you need.
Oh, plus 18,000.
That's the number of hosts, so you can multiply that by 7 to get the number of pounds of.
Yeah. And then how many total deaths? How many people are there total?
That has to be 18,000 plus.
For the lab today, are we turning it in right after class is over, or continue this next class?
Yeah. We're going to just collect data today
Okay.
and continue the report later.
So if we don't have, cause I have the book, I just left it at home. So,
You're okay.
all right.
Overall goals.